Hello everyone. In my last video, I have talked about maths required for data science. Over there, I have mentioned about statistics, linear algebra, and calculus. So in this video, I will be starting with the statistics, and in my later videos, I will be talking about linear algebra and calculus. So topic for today's video is this thing, what is statistics, what are the terminologies and the types of statistics we have. Now let's get started. So for this video I have already written all these things so that I can save some time and explain more about the concepts. So statistics is basically an area of applied mathematics concerned with data collection, data analysis, data interpretation and presentation. So, in what all scenarios you can apply statistics and where you can use, I'll explain this with an example. So, your company has created a new drug that may cure cancer. How would you conduct a test to confirm the drug's effectiveness, like whether it will be able to cure cancer or not? So, you can find such kind of things using statistics. Let's take another example. The latest sales data have just came in and your boss wants you to prepare a report for management on places where the company could improve its business. So what you should look for in a data and what you should not look for and what all things and how you can analyze your data, all these things you can do with the help of statistics. So in such scenarios you can apply statistics. Now let's come to the terminologies which are used in statistics, that is the population and the other one is the sample. So population is the entire data present in this world or like or on internet everywhere. So it is like huge amount of data or the complete data present in this world, and sample is the subset of the population. So there are few notations with regards to population, that is it is denoted by capital N, and number obtained from population is called parameter. So please make a note of this thing, this parameter information. And for statistics, it is denoted by small n, and the number obtained from sample is called statistics. So I think now you got idea from where we are getting this statistics, that is the from sample. So I'll explain this with an example. So when I'll explain to example, you will get more clear understanding. If we want to perform survey of job scope for students studying in NYC University, what we do? So we collect the data from the population, right? But it's not only people in NYC campus. So there are a lot of people who are studying in NYC, but they are studying abroad, distance, or part-time, or enrolled, but still in high school. So in this case, population is hard to find and hard to observe in real life. Whereas sample is easy to gather, it is less time consuming and less costly compared to population. So as you can see and understand, like population is hard to observe and sample is easy to observe, and population is hard to collect, like you cannot collect the data of the entire world, right? It makes sense. No, we are human being and we cannot collect the data of entire world. It's like beyond our range. And sample you can collect it. So there are two things you need to know about sample. These are the properties which a sample should have. So for this example, what I'm doing, I'm just gathering the sample by talking to people who are present in the canteen. So I'm not talking to people who are present in, who are doing distance education or who are there in the classroom. I'm just going to the set of people who are sitting in a canteen and I'm talking to them. And I'm talking about the job scope and etc. With only these people. So now I'll come to this point. sample should have a randomness and representativeness. So when I say randomness, it is like data should be collected randomly. It's not like it's collected from one source. We should collect the data from different sources, and then only we can bring randomness in a data set. The second one is representativeness. So your data set should be collected so accurately that it reflects the member of entire population. It's not like you have collected data from one part and you have just ignored the other data present in the other part. So you should collect the data evenly from the entire population. So if you see here, now I'll come back to this example. So the data which I have collected for sample is from the people who were sitting in canteen. So if you see, there's no randomness, okay, because I have not randomly collected data from people who are at home, who are studying abroad or distance or like other people. Also, the representativeness is not present because it's not representing the population of the entire people, right? It is only representing the information from the people who are sitting in a canteen. So in this case, even if you go for this kind of sample, it will be of waste. It will not draw any kind of good inference, and it's not at all useful. So this is all about statistics. Now I'll come to the types of statistics. So there are basically two types of statistics: descriptive statistics and inferential statistics. So when I say descriptive statistics, it means I'm talking about the data. That is, it uses the data to provide description of the population either through numerical calculation or graph or table. It is mainly focused upon main characteristics of the data, and it provides graphical summary of a data. I'll explain this with an example. So you want to give t-shirt to all the students of a class. For this, you have to study what is the average size of a t-shirt in a classroom. After that, only you will find out the maximum, average and minimum size, right? So in this way, you are studying the data, you are gathering the information about the data, and it's all about the description of the data. The second one is inferential statistics. So it makes inferences and prediction about a population based on a sample of data taken from population in question. It generalizes large dataset and applies probability to draw a conclusion. And it also allows you to infer data parameter based on a statistical model using a sample data. Again, I'll explain with the same example. So if you want to give t-shirt to all the students of a class, then instead of considering entire population of a class, it will take only sample of group of people in a class and summarizes. So you don't have to go to each and every student of a class can ask for the size. You can just draw an inference from the set of people, and then you can predict like what should be the size of the t-shirt which you should design for the students in a class. So that's all about the definition of the statistics and inferential statistics. Then I'll come to the types of descriptive statistics. So it is basically of three types: measure of central tendency, measure of spread and variability, measure of asymmetry or skewness. So first I'll talk about the measure of central tendency. Under this we have mean, median and mode. So mean is like everyone knows from its very basic concept, like from plus two we know what mean is. It's arithmetic mean or the average. It is represented by mu. So for the population mean it is represented by mu symbol, and for sample mean it is represented by x bar. And this is the formula for calculating the mean. It's very simple. You just have to add all the data points and divide it by the number of data points available. And one thing you have to note about the mean is like it is affected by outliers. So for people who don't know what exactly outlier is, I'll just quickly explain. So outlier is basically like I have some data points in my sample space. So it's a 2D diagram I'm talking about. So I have data point here, okay? So these are my data point. So all my data points are lying in this space, feature space, okay? But there might be possibility like you will find some data point here, some data point here. So these are nothing. So these unrelated data points in a feature space is called outlier. So now I will explain how mean are affected by the outlier present in a data set. So this is the example I have taken. So it's about these are the prices of pizza from some restaurants present in NYC and LA. So here you can see the prices are in dollar. So $1, $2, $3, 5. These are the prices. And for LA, it is like same in the form of dollars. This thing, and also you can see if you can just observe that this data, you can see over here. This is like the outlier. So in the data set here. So if you see the prices of pizza like 1, 2, 3, 5, and like very less differences there, right? But if you see the price of pizza here is $66, which is very expensive. So why we have the price of pizza as $66? So there might be possibility like in some posh restaurant, like the prices are very high due to ambience and other things. So if I'll just calculate the mean in NYC, so I'm getting over here, the mean is $11, like which is higher, okay. Uh, so it's getting higher because of this part, okay, due to this outlier. But in mean in LA, if you see like all data points are like fine and there's no outlier present over here, and here the mean is like almost fine. So the problem here, I was talking about this thing, right? The outliers. Mean are affected by outliers. So here we have the outlier 66, and the mean, because of this outlier, the value of mean has increased a lot, okay? So that's why we cannot rely on the mean. So it will not give you accurate prediction or accurate conclusion about the data. So in that case, what we can do, we can go for another measure that is called the median. So what exactly median is? Median is a measure of central value of a sample data set, or you can say middle number in a ordered data set. So when we talk about median, the data set should be sorted, or I'll say it should be in ordered format. Okay, it should not be like it should be in increasing order. So then again, there are two ways to calculate a median. So it depends on the n value. So n is the number of data points. Okay. So if the number of data point is odd, then what is the median for the data set? So median is the middle value. Okay. So I'll just explain with this the same example. If you see here, the number of data points over here is n equals to 11 for this case, for the data points present in NYC. And here you can see, so the formula for calculating the median in case n is odd is n plus 1 divided by 2. This position we have to talk about, okay? So n is what exactly the n is? It's 11 plus 1 divided by 2. That is sixth position we have to. So whatever the data set present, data point present at sixth position, that is our median. So I'll just calculate 1, 2, 3, 4, 5, 6. So this is my median in this data set, okay? And when n is even, let's take another example. So here you can see the number of data points are 10. So when n is even, you have to add the middle two elements and then find out the mean. So here the middle two elements are this.